Here is a sorted array where values can repeat. 2, 5, 5, 5, 8, 12, 16, 23. We want to count how many times a value appears. For 5, the answer is 3. We could scan the whole array and tally, but on a sorted array binary search lets us find the count almost instantly. The equal values sit together in one solid block because the array is sorted. So if we find where that block begins and where it ends, the count is just the gap between them. Lower bound gives the first position whose value reaches the target. Upper bound gives the first position whose value goes past it. Subtract the two and you have exactly how many copies live in between. 2 fast searches, no full scan. The first loop is a lower bound. It finds the first index whose value reaches the target, and we save that as first. The second loop is an upper bound. It finds the first index whose value is strictly greater. The difference between that and first is the number of copies of the target. Let's build the two boundaries live and subtract them. First, we run a lower bound to find where the block of equal values begins. Then an upper bound to find where it ends, and the count is the difference. Now let's test it and hit run. There we go. 5 appears 3 times. 8 appears once. And 99 is not in the array at all, so its count is 0, because the two boundaries land on the same spot. The idea in one picture. Lower bound marks where the block starts. Upper bound marks the spot just after it ends. Subtract to get the count. If that count is 0, the value simply is not there. We do 2 binary searches, each having the array every step, so the total is order log n time. That is a huge win over scanning the whole array. We only keep a few markers, so the space is order 1. 3 things to remember. First, this trick only works because the array is sorted, so equal values sit in one block. Second, the count is upper bound minus lower bound. If you instead use last index minus first index, remember to add 1. And third, when the value is missing, both bounds meet at the same place, so the count is naturally 0.